broadcasting live from the Auburn Hills Tech Center. And today we're going to be talking about setup on wire EDM machines. So let's give you a quick overview of what we're going to go over today. As I said, my name is Brian Coward. I'm going to be doing a little presentation here. We're also going to have Taylor Cox, one of the applications engineers here in Auburn Hills. And he is going to give us some demonstration at the machine of wire EDM setup techniques. So we're going to go over some setup challenges in the wire EDM, what makes it unique to other machines. We're going to go over some wire EDM tooling that's available. Also, there's a touch probe option that we're going to talk about here on the wire machines, and also a 3D plane find pickup function. So presentation will go over this. During the presentation, we're going to go back and forth. We will go out to the showroom where Taylor will show us how the EDM tooling functions, and then he will also give us a demonstration on the 3D plane find pickup. Okay, so to start off, wire EDM setup techniques. So that's what we're going to talk about, and why is it unique? Why are we having a presentation about this? Well, the first thing with setting up a wire EDM is, or any machine for that matter, is the interface of the control. How user-friendly is the control? Makino uses our Hyper-I control system. It's the quick, easy interface. It is a universal control for wire and sinker. So very easy learning curve for an operator, which makes pickups faster and more productive. It has a 24-inch touchscreen. Functions just like an iPad or a tablet or an iPhone. Also, you have your onboard digital manuals on the machine, and there are also instructional videos as well. So for the wire EDM setup page, this is the initial page. As you can see, a very graphical representation of any pickup cycle that you want to run on the machine. So you just click on whichever pickup you wanted to do. So for example, if I wanted to pick up a round hole, I could just press that button, and that'll take me to this next page. So right here is the hole center pickup. It's an example of that. Each pickup cycle, there are instructional videos for, okay? If I need any help, I can hit the little icon right there, and it'll take me to the EDM assist. It will have an instruction manual to tell you about each pickup cycle, and then also there are embedded videos in there as well to assist you with your pickup. You see down below here, it's giving us our X width and our Y width, and so I can actually measure the part before I take it out of the machine. I can also save that to an Excel file if I need it for future reference. So why is wire EDM different than other machines? So by this picture here, you can see this is a part set up in the machine. The difference between sinker EDM or mills and wire is that there is no table underneath the part. So you have to set the part up, and it has to hang off of the rails to be able to machine it. So for example, this part, if I had to cut 3 sides on this, this is how I'd have to set it up. So if I'm just clamping that to a table, it's going to sag and fall, okay? Even if I take that part and I put it on 2 rails, right here, the opposite corner is still going to sag. So for me to set up that part and make it flat, I'm going to have to indicate it back and forth, indicate the top, shim it up. So it's very time consuming. So what are some options to assist in that problem? Well, we can get some wire EDM tooling. So there's rail systems that bolt to the existing frame of the machine, and that would be for larger parts, right? So you want to put a larger part in here, supporting it on 4 points. It's going to keep it nice and flat. For small to medium parts, there's various clamping devices, vices, rails, things like that. But the big thing with this is I can have a leveling head on that tooling. So that leveling head is going to allow me to adjust the C-axis to indicate the part is straight, but I can also control the ZX and the ZY plane And it's a very quick, easy way to get the part indicated in straight. So now we're going to do a little demo of that tooling. So we're going to go out to the showroom, and we've got a video here that's attached to the machine right here, and Taylor Cox is going to be out there, and he's going to show us how this tooling works. Okay, so could you give us a demonstration on this 0-point tooling here and show how it works, please?
Absolutely, Brian. Thank you. So here we have our 0-point leveling head. Inside we have a workpiece. And what we're going to want to do, just like what Brian was speaking about before, is I'm going to want to make sure that my part is sitting in the machine level. So having this leveling head where I can, lean on DX, DY, and C-axis really helps to get the part set up quick and easy. So first thing I'm going to do is I'm going to take my dial indicator, and I'm going to get on the side of my part here. Okay. Now this one, you really can't see my dial from the camera angle, but I'm going to be making sure that we're skewed this way, normal to our y-axis. Okay, set my 0. And we're slightly off. So what I'm going to do here is make a small adjustment. And now my C-axis is set. Now, switch my indicator around, and now what I'm going to do is I'm going to get the top plane of my part. So let's take a look. We'll see what we look like. So we're about 20 micron or so, about a thousandth. So what I'm going to do here, run my indicator across and make an adjustment here. Run back and forth. Okay, now I'm about 10 micron or so. Five. And now we're about 3-4 micron. For this setup, that's okay for what I'm doing. And then now I'm going to go in the Y direction here. About 4 or 5 micron off the start. Make a small adjustment. And we're 2-3 micron right now. So in just a couple of minutes, just like that, I was able to orient my part in my C-axis and my ZX, ZY. Now I'm leveled. I'm ready to get this part set up, picked up, and ready to go. So, Brian, I'm going to pass it back along to you.
All right, thank you, Taylor. Okay, so you can see how that tooling helps with setup, makes it much simpler, much easier for the operator to set up, okay? So that's one option, right, to assist in wire EDM setup. Okay, another thing is probe capability. So people are very familiar with probes on milling machines. It's a very common thing. I know on sinker machines as well. People don't tend to think of it for a wire machine, but there is a probe option for wire EDM machines, okay? This uses a high accuracy Renishaw probe. The probe arm is manually loaded using a row chuck. So you can see in the picture right here, that's the configuration when the probe is on. And then when the probe is off, there's a little cover plate that goes into the chuck there on the side of the machine, okay? The way that this functions is when you set up the probe, you do an initial setup and the machine automatically knows where the center line of the probe is in relationship to the center line of the wire. So when I use a probe, I can do any pickup that I could do with the wire. So any existing 2D wire pickup cycles, hole find, corner find, edge find, all that kind of stuff, I can do with the probe, okay? The probe does provide a higher actually pickup because the probe itself is more accurate than the wire, and you're also doing a 1-point pickup with the probe. So it does assist with your pickup accuracies if you're looking for super high accuracy. But it also does some 3D pickups for us. So it will allow for a 3D leveling of the workpiece. It's called advanced 3D plane find. And the way that this functions is the probe will come down, take 3 points on the part, just like you would on a CMM, and it will align itself so that the wire is perpendicular to that workpiece condition, right? So we don't have to worry about it sagging a little bit in that setup example that I showed you. This pickup cycle right here is what it looks like on the Hyper-I control. So it's not just for picking up the top of the part, although that would be the most common that you would do. You would pick up the top of the part. You can pick up any surface. So you can see right here, 1, 2, 3, 4. It just changes which side of the block I'm going to pick up to align off of. So I'm going to show you a little video here that displays or demonstrates how that cycle works. That calculation, it will move my UV axis according to the part, and it corrects also is correcting my A alignment or my skew of the part. So by using that probe, you can pick up the top of the part, the side of the part. You can do alignments for the UV axis, and as well as indicating the part end. So it saves you from having to indicate the part. So that is one option to make setup easier. Also, on every Hyper-I control machine, there is an existing function, okay? And it's called Wire EDM 3D Plane Find. And what this does is, just like you saw with the probe there, we can use an indicator and we can capture those 3 points to be able to level using our indicator. Similar to the probe, but it is a manual cycle, okay? So we're going to go out to the showroom again, and we're going to have Taylor give us a demonstration on how that 3D plane find function works. Okay, so could you give us a little demonstration on how you would record those points?
Absolutely. So we've got this plate sitting in here. We've got it blocked up, so it's really sitting skewed like this. So first thing I'm going to do, like what Brian has said, is I'm going to bring my indicator down onto the top of the workpiece here. And I'm going to bring my indicator down until it reads 0. Now my indicator reads 0 on the screen control. Hit the Get Position button. Then bring my indicator up. Move it to the second point here. Bring it back down again till it gets to that same 0 point. Okay, now we're at our 0 point again. Hit the second Get Position button. Bring my Z-axis up again. And then move over to our third position. And bring it down one more time. And hit the Get Position again. So now we've recorded those 3 points that define this top of this plane. Oh, make sure I raise my indicator up off the part. Then on Hey, Brian.
Okay, Brian. Yes, sir.
Can you hear me?
I can hear you.
Okay, sorry, we lost audio connection.
Okay, yep.
Okay, so after I get those 3 points, then we're good to go. Press one button on the control, hit the start key. Now my UV has shifted, okay? Now what I can also do, if I want, if my block is misaligned in this direction, okay, I can also use my same dial indicator and do the same exact thing, okay? Get my dial indicator set up here, move my axis over, and come in. So my indicator reads 0, switch to that work rotate page, get position for the first position here, move to the next point. We're taking 2 points here to define this line of angular rotation. Come in until we get to our 0 again. Hit the Get Position. Again, move my indicator off the part now that it's calculated, and compute to the angle A. So now on my machine screen here, I can see the measurement result for the U-axis, the V-axis, and the A rotation. All very simple, easy using a dial indicator, which everybody in a shop has. So, Brian, we're going to head back to you.
All right, thank you, Taylor. Okay, so as Taylor said, I want to point some things out here before we have some questions. So on the pickup screen here, if you look on the side right here, this is the 3D plane find. And so what Taylor was doing right there is he was recording these positions. Right here on the slide, it's 0, but he was recording the first position, which is in the yellow, and it records your X, Y, Z position of the machine. Then you take the second position in the green, does the same thing. And then the orange, it'll do the same thing. Okay, so you record those 3 points, you just press this Get Position button, and then it'll calculate your U and your V angle rotation, just like it did with the 3D Pro, okay? And up at the top there, you see plane measure and work rotate. So when he did the C alignment, or the A-axis rotation, you go to work rotate, and you would take 2 points on the edge of the block, and it'll give you your A angle down here. So that's how that function works. That function is standard on every HyperEye control machine for Makino. So just to kind of go over, to make your setups faster. We've got tooling that you can use with leveling heads. I highly recommend that. It's going to save a lot of time in your setup process. You have a probe option that's available for wire EDM, similar to probes that you use on your mill or your sinker EDM. And then also standard on the machine, we have the plain 3D option. So that's our presentation for today on wire EDM setup. I just want to thank everyone for taking this time to spend with us this afternoon. Feel free to contact your local Makino representative if you have any questions about any Makino product whatsoever. If you have any questions concerning wire EDM setup, this presentation we did right here, my contact information is right here on the screen, and I encourage you to contact us with any questions you may have. And if you want a one-on-one demo, we can schedule that. We can use the same technology that we used here today to give you a more in-depth presentation of whatever you would be interested in. So thanks for joining us today.
Okay, so that was our presentation about wire EDM setup techniques. Myself and Taylor are available now if you have any questions about anything that we talked about or anything else that you may have questions about concerning wire EDM setup. If you look on the right-hand side of the screen there's a chat window. You can type in any question that you have in the chat, or there's also a Q&A section where you can type in any question that you may have concerning wire EDM setup in there as well. Okay, so I did have one question that was asked earlier. So in the demo, if you notice, the leveling head that we used was a 0 point. That was the brand name, and it was bolted directly to the table. Customer asked me, they've seen leveling heads that have a chuck that is bolted to the table, and then the leveling head is attached on the chuck and then removed off the chuck, and the chuck always stays there. So Taylor, can you tell me a little bit, what's the difference between the two, and is one better with a chuck or without a chuck, or is it just more of a personal preference type of thing?
Yeah, Brian, I can. So the main reason to have the chuck is for repeatability in positioning. So if you have the chuck, you can repeat and load that chuck multiple times on and off, and it's always going to repeat to the same position, your same XY position. A lot of people will do stuff like that, essentially getting set up to run automation, right? Because if you're loading with a robot, you're going to always want to be in the same position, but not always does it have to be with a robot. A lot of people also will basically have a chuck on the machine, whether pneumatic or a manual chuck, and they'll do preloading off of the machine. So they'll have a secondary setup station, essentially, and they preload multiple chucks while the machine's running. So as soon as the machine stops, they can pull one part out of the machine and run it in with the different one. So that's when you'd have something with a chuck. There are items without the chuck that essentially still gives you all of the leveling capabilities without the added cost of that, precision chuck, the precision repeatability device there. As far as is one better than the other, it depends on what you're trying to do. Do you just need leveling capabilities? If so, I'm not going to spend a bunch of extra money if I don't need it for positioning, right? But yeah, if you're going to be heading towards automation, if you're going to be heading towards presetting multiple tools at once offline, then I would look at tooling that has the chucks.
Okay. Yep, that makes sense. Yep, understood. There was another question as well about the probe.
Mm-hmm.
So in the video, it's a rent-a-shop probe, obviously, and the probe tip that was on it, I think, was a 2 millimeter diameter.
Yeah.
So, but are there other diameters that you could put on there in terms of the probe tip if you wanted to.
Yeah, absolutely. It's those tips can come off. You can change that tip diameter. Essentially, when you do your calibrations in your setup, you can change to whatever type of a diameter you want, custom stylus. That's all going to be done when you set up the probe. But as far as after that, you can continue to use it.
Okay. So that would really depend on the type of parts that you were running and the type of probing that you wanted to do, right?
Correct. I mean, usually they start off with a relatively small probe because a lot of the times, really, you're using it just to pick up orientation. But let's say, for example, you have some holes that you're going to use to pick up for rotational alignment rather than the outside of the block, or you've got a small slot and you want to pick up on that slot for location. That's why you're going to typically see a small stylus on the end there, just so you can get into that small geometry.
Okay. Very good. I'm looking, and I don't see any other questions coming up. So if nobody else has any questions, again, I want to thank everyone for spending time with us here today. And if anything comes up, you have any other questions concerning wire EDM setup techniques or anything related to EDM, feel free to contact me or Taylor, and we can answer any question that you may have. So thanks, and everybody have a great day.
Thank you very much.